Welcome everyone. Thank you all for joining our webinar on offshore wind project development in Italy. We see a lot of you are joining and thank you very much for that. So let me first introduce ourselves and explain what we will be doing in the next 50 minutes. So my name is Imke Maassen van den Brink. I'm a director at AFRY Renewables in Netherlands, also heading AFRY's Global Offshore Wind Competence Center, because our offshore wind activities within AFRY and the technical consulting services that we deliver are centrally organized from this competence center. So together with me, I have Leon Hofland, principal consultant in offshore wind, and I have Hendrik Goos, founder of. In the next 50 minutes, we will tell you more about offshore wind project development, and then specifically in the context of Italy. So of course, we're aware we cannot tell you everything about offshore wind project development within 50 minutes. So we will touch upon everything that is important, but for a full course on offshore wind project development, we will also tell you a bit more about a 2-day course that we have set up and that will be held in Italy, but that will come all the way at the end of this presentation. So, of course, we will touch upon the main components of offshore wind in a wind farm and its grid connection, but also the regulatory framework, the fundamentals of the business case for offshore wind, and of course, different stages of project development. But first, very briefly about ourselves and our company. So AFRY is a leading technical consulting design firm with about 20,000 people spread over 50 countries, among which also Italy. We have 2 offices in Italy. And what we do is we offer sustainable solutions in the area of energy, industry, and infrastructure. AFRY has been active in wind for almost 30 years. It started, of course, with onshore wind, but for the last 15 years, we are also active in offshore wind. And what we do is we deliver cutting-edge engineering and technology services combined with strategic and commercial advice. And we do this throughout the entire project lifecycle. As mentioned, we are centrally organized with our technical consulting capabilities from the Utrecht office, but we collaborate intensively also with the local offices and of course with the different disciplines within AFRY, such as, for example, the management consulting and commercial teams, but also the transmission and distribution area. So far we've already helped developing over 70 gigawatts of wind projects as technical advisor, but also over 90 gigawatts of wind projects as commercial or strategic advisor. And I'd like to hand over to Hendrik. Hendrik, can you tell a bit more about Green Goose Solutions?
Yes, thank you, Imke, and buongiorno, everybody. My name is Hendrik Goos, and I'm the founder of Green Goose Solutions. And I'm an independent energy consulting company. And what we do with our main business is designing and implementing specialized industry aligned training programs for the energy sector. And I've been doing that in various countries, including North America, Asia, and Middle East. And I have a proven track record for international institutions and organizations. You will see some pictures in the presentations that I took because I'm still working in the offshore wind industry. So I like to bridge the experience that I have and the industry that I meet with education, and so actually enhancing the green workforce.
Yeah, Thank you very much, Hendrik. So before we continue with the actual offshore wind project development webinar, I would like to tell you a little bit about the the practicalities of this webinar. So what you will see in the slides that we're going to present is mainly generic info about project development, but we've also included gray boxes, which is the customized info for the Italian market. Though you can also recognize those by the Italian flag. Also, if there are any questions, you're free to ask those via the chat. We'll try to incorporate your questions into what we tell you today. But if we cannot already answer all of your questions, we'll come back to you with written answers after this webinar. And then the last item, don't bother to take print screens of the slides that we are presenting, because we will share this slide deck afterwards with all people that participated. Good. Then let's continue with the offshore wind project development. Hendrik, up to you.
Yeah. Thank you very much, Imke. Right, here you have an overview of a wind farm. So to your left, you see both the bottom-mounted turbines as well as the floating turbines in an offshore wind farm. You see them being connected through inter-array cables, eventually to a offshore substation that you see right in the middle. And that offshore substation is then connected to the onshore substation, as we call it, or some people call it a point of connection. From then on is the TSO, so the transmission system operator in your country that connects it to the grid. Now, it's a few things, because most people only see the turbines floating or standing up in the water, but there's more going on than you think. So the electrical structure that you have, but also the foundations and the offshore substation and connecting to the grid is actually the largest part where it comes down to costs, complexity, and the risks that you take. So whenever you win a concession in most countries, just like in Italy, you see the responsibility is to the very concession winner. So the responsibility for the grid. So you see in most countries, it will be up until the point of connection. But there are also countries like our country in the Netherlands, where the Dutch government has said, no, we have the TSO, and our TSO will take care of the offshore substation and all the way through, so the export cable towards the point of connection, and then eventually it's up to them, of course, to distribute it all over the grid in the country. And that's an important difference. Like I said, Italy is already the case, but it's also in other countries. So, yeah, when you look about the turbine, because that's the main thing that you see, you have a few choices to make. So one of them is the turbine rating and the size. In other words, we go for 3 megawatt turbine or 10 megawatt turbine or a 12 megawatt turbine. And the thing that you have to think about there is, how do I transport it? How do I install it? What are the constraints there? And also looking at the supply chain availability. So which turbines are available at the moment? As you know, a lot of countries have offshore wind in their energy mix, so and it will become larger and larger. So that's one thing to think about, the turbine rating. Do I go for larger turbines and maybe fewer foundations? And then you go to the tower and rotor configuration. So how high would you like to build it? Because the higher you build your wind turbine, so the larger the hub height, the more wind you can catch, and also will be wind with less resonance. It's important to note. Also, to catch the wind, of course, you need your blades. Your blade length is there important, and also your material choice. So how thin do you make your tower? What kind of material are you thinking about? Think about weight, but also what are the loads that come against your monopile foundation. Looking at structural loads, like I said, but also your transport and installation constraints. One of the things that you will find is that a turbine like that could weigh anywhere between 300 and 800 tons, including the blades. So finding a good vessel for your installation, it could be quite difficult. So that's something to think about. Last but not least, you have your drivetrain. I've given you a picture on the bottom here. So a gearbox driven one, but also the direct drive one. So gearbox, you have your low speed and your high speed going into the generator, and with the direct drive, you go straight into the generator. Problem there is it's costing a bit more and it's a lot heavier than the gearbox driven one, whereas the gearbox driven one needs more maintenance. So that's a choice that you will have to make. So once you made a choice about turbines, also thinking about the support structure configurations, there are quite a few of these. So when you look at the picture below, you have your fixed bottom foundation. So think about monopile, think about gravity-based, the tripod and jacket. And the reason for choosing those is water depth, seabed limits. If the seabed is not very consistent, you might as well go for gravity-based. But if you have a lot of load conditions, so the water hitting against the foundation, for example, and you are in deeper waters, then a jacket could be a good solution as well, as a jacket is much stiffer than a monopile. Monopile, of course, is the most cheapest way of foundation. Then, of course, you got floating, and there are, what I've been told to believe, more than 120 different designs. But this is just a few of these. So sub tension leg platforms on which you're actually pushing it down towards the seabed. And the spar, and the one thing that you notice, of course, is the anchor lines and the mooring lines that you need for it to be in place, including the different anchors that you need. And per situation, you will look for a different anchor. Now, all of these foundations are great to look at, but of course, when you look at the picture to your right, you see, okay, what kind of projects are we looking at for Italy? And you can see that some areas are suited for bottom fixed, which is the lighter blue, and also which areas are used for floating. And you can also see that for floating, and we think that it could be a capacity of 18.5 gigawatt, is much larger than your bottom fixed or bottom founded foundations. So that's something to think about for you guys. Now, once you've got all that, you also have to think about your grid connection system options. So are you going to go for alternating current, which is the most simple and easiest way basically to transport your electricity, or will you go for direct current, which actually enables you to transport efficiently much more electricity over long distances? But of course, it's much more expensive. When you look to your right, offshore substation, so we go for a centralized substation, so one substation or maybe two per turbines, or we go for distributed. Distributed gives you a chance of being more reliable, and that's something also to think about what you would want to do. But what we see is that you're probably more forced into the more centralized way of doing that. The physical routing of export cables to the shore, well, either you go for the shortest route, so basically you lay your cable from where your wind park is to where actually the energy can be collected, or you're going to go for a route that actually avoids constraints like environmental constraints, but also is there any other marine activity there? Or maybe the seabed has some changes as well, like moving dunes, that kind of thing. So that's something to think about too. Finally, look at the integration with the onshore grid. So you could be like grid following. So what you do there is you provide the electricity that you have straight into the grid. Also, another point is to look at the grid forming. What you do there is you look at more at the stability of the grid, and you are working towards that in a way being part of that. So This will be the last slide before I hand over back to Imke, and I will go over this very short, because this is a slide that Leon will talk about much more than me. So you can divide the project development into a few phases. So feasibility phase, development phase, contracting phase, construction and operation. And here you have an overview of the project value, but also the risks in a slightly darker gray, I guess it is, and also the development costs. And here you see a nice overview. And this is a bit like a teaser, because I know that Leon will definitely talk to you about this later on. It's a very short overview. We will talk about the foundations and the turbines much more in detail during the course. So I try to keep it as short as possible, which is nearly impossible for me, but I've tried my best. So I'll hand over now to Imke for the permitting side.
Yes, thank you very much. So I will tell you a little bit more about the regulatory framework, which is actually different for each country. And what is different is the tender mechanism and the permitting process. So just to give you an overview to start with the tender mechanism. So what defines these different mechanisms is mostly who initiates the project and who takes the initial risk, for example, by performing the site studies. So in a centralized tender mechanism, it's the government that tenders a pre-selected site and a pre-developed site. So they commission already the site studies and they define what site is to be tendered. Afterwards, so after the biddings have come in, they grant the key rights and permits and licenses for a developer to develop, build and operate the offshore wind farm. So what's clear here is that for the developer, the risk is lower with a centralized tender mechanism at the early stage of development. While with an open door mechanism, each of the developers select a site themselves, and they are also responsible for conducting the site studies and also for obtaining all of the necessary rights, permits and licenses for the development, building and operating the offshore wind farm. So they already need to take more risk, spending more money in an early phase of the project. Looking at the permitting processes, there are also two variants. There's the one-stop shop, where all permits are granted simultaneously via an integrated process, mostly also coordinated by a single authority, while in the multi-stage permitting processes, the applicants must manage each of these permitting processes, and normally it considers multiple permits or licenses, and they need to do that either simultaneously or sequentially, and often also with different authorities. So it's a bit more complex, and it is also different for each of these developers. So what you see here on the right is the process for the permitting for Italy. And what we know about the Italian tender mechanism and permitting process is that it's an open door tender mechanism. So each developer can select and start developing their own sites. And that is a multi-stage permitting process. I will not go into the details, but what's important to understand is that it concerns 4 permits, and the total duration to obtain all of these can take several years, but it also varies per developer or per project. Leon will also tell you a bit more about these permits later on. Then another important aspect of the regulatory framework is the role of support schemes, because we do see those included in most countries, even if they have been gone for a few years, they're again implemented. And why is that necessary? Because, well, you will all know that, of course, offshore wind projects have a high cost of, have high capexes, initial capexes. The revenue is, of course, relatively uncertain because of fluctuating power prices, and they have long development timelines. And in those timelines, a lot can happen. External market conditions can change, but also the regulatory framework in a certain country can change. And that together with also risk and uncertainties associated with the technology, because although it's a mature technology, offshore wind itself, some of the components are still relatively new, such as, for example, floating. So there is uncertainty there as well, and also uncertainty in the timely availability in the supply chain. So all of these increase the risk, and with that also the cost of capital. And for a project to be well, bankable, because most of these projects are financed via external debt, what is necessary is not just another source of income, because that's of course what a support scheme could deliver, but mostly also a secured source of income. So that is mostly the added value of the support schemes, such as subsidies. Another thing, so why would a government actually support the renewable technologies if a subsidy is necessary? It's because they also have a system value. So it's not just about the electricity produced by these technologies, but also, of course, the carbon emission that is avoided. And it also increases the security supply of a country. So there's more value to it than just what is priced in per megawatt hour for this technology. So different forms of support schemes are, for example, the feed-in tariff, which we saw at the beginning of this millennium. After that, contracts were different for multiple renewable technologies, among which offshore wind, introduced, for example, in the UK already a long time back. But now we see that these contracts for difference are adopted by multiple countries, but also in different forms. So mostly two-sided, which means that also windfall profits are avoided. A ceiling tariff, there is a cap to what a developer will get from the government, but also other design options are important when you define a CFD, such as indexation, but also how do you deal with negative prices. So in Italy, they are considering a two-sided CFD, but we'll come back to that a bit more later. Then the last thing I'd like to mention are the importance also in the introduction of the non-price criteria in the tenders. This is a trend that started a few years back, mostly in the mature markets. I will not go through all of these different categories, but as you can see, there are a lot of categories that are currently being considered for non-price criteria, and these non-price criteria are either applied as pre-qualification criteria or as award criteria. Most countries that we currently see that apply these criteria at least have criteria related to the environment, but also to innovation and local content requirements. In Italy, at the moment, there's no use of non-price criteria in the bid evaluation. However, you could say that they apply environmental criteria in the pre-qualification, because there are quite strict environmental obligations when doing your environmental impact assessment. So Italy has the price only and open door auction for offshore wind at the moment. Then let's continue with the fundamentals of the business case, and therefore I'm giving the words to Leon.
Thank you, Imke. I'm gonna indeed talk you through the business case and some of the generic principles of project development. So to start with the business case, I first like to introduce you to a very useful metric, which is called the levelized cost of energy, or LCoE. Maybe a lot of you have already heard of that. It's a very useful tool. What we do there is we take all the costs that we think, the discounted costs, I should say, that we are predicting over the course of the life cycle of the project. So starting from your feasibility towards potentially removal. We add those all up, and then we predict how much energy we're going to produce over the operational lifetime. We divide that, and then we get a metric, the cost per produced unit of electricity. And why is this so useful? Because it's a cost. It shows you the price for the cost point at where the project becomes feasible. And if it's higher, less feasible, lower, more feasible. So you want to have the LCOE lower. What factors play into that? Of course, if you have higher costs, mainly the CAPEX and the OPEX, the operational and maintenance costs, those feed into that metric quite heavily. What that also feeds into that is the WACC factor, the weighted average cost of capital, or how expensive is the money that you need to secure to build your plant. And of importance there are your interest rate, your return on investment expectations, etc. Now, you can also optimize the LCOE not only by reducing costs and reducing your risks, but you can also try to produce more, having a higher capacity factor by smart design or selecting the right turbine, and also increasing the availability of your turbines, which means that they are operating a higher percentage of the time. That, of course, ties back to a proper operations and maintenance strategy. So while these factors all affect the LCOE, how does it work in practice, and why is the LCOE so useful? Well, to answer that last question, because it allows you to play around with it and make choices that optimize the business case. And then we're not only talking about technical choices, your design, but also the financial framework. So, for example, in the beginning of the project, when we check the feasibility, we set up an LCOE model. We put in our first ideas about the turbine, the size, what power we get from it, the site layout, where we place the turbines, a bit further apart to optimize wake effects. Or maybe we tailor it to the soil conditions, talking about that, what foundation type suits those soil conditions the best. And of course also, as Hendrik explained, the grid connection part, the cables were very important choices to make. On the financial side, of course, we need to know what is the WACC factor. We also need to look at, are we going to express the LCOE pre-tax, post-tax, in real or nominal value, or risk strategy. All that feeds into an LCOE model. That gives us that final answer, the point where the business case becomes viable. And what we do now in those early stages, we are going to vary. We take one parameter and we change it. What happens if we have a different turbine? What if you change the site layout? What if your cost of capital goes up? And what does it do to the LCOE? And this gives us insight in the business case. But then we're not there yet, because we are talking about cost now. We also need to look at the revenues that we're expecting. So then we have to look at that support scheme that we hopefully are securing, your power agreements, what we expect to get back for your electricity. And together with the LCOE, that gives you an insight in your investment viability. LCOE analysis is very important in early stages, but it doesn't stop there. Even when you have reached your financial close, you're already constructing and building, you keep on tweaking the business case and optimize it. And that goes as far as in the operational phase, where you might, for example, switch your service provider to increase the operability of your turbines or other assets. A closer look at the costs. We thought it would be very interesting for Italy to compare costs for fixed and floating developments. The two pie charts here are equally large. Let that not fool you into thinking the costs are equal. These are relative costs. We thought it would be interesting to show you the contributions, the foundations, the turbines, and etc. And what do we see then? For floating, most strikingly, the foundation take up a much larger relative part of the capex than for fixed. And maybe that doesn't surprise you, where for foundation we have decades of experience in standardizing and mass producing the fixed foundations. It's mainly monopiles, which are also relatively easy structures for design and installation. That's not the case for floaters. That is more of an emerging technology or more complicated to build and more challenges for mass production. And of course, the floaters come with the additional equipment, the mooring lines, the anchors, like Hendrik said. Every site needs a different kind of anchor. You have winches, control systems, and that all adds up. What might surprise you more is that the construction, installation, and assembly costs are relatively lower for floating. And that is because floating gives an opportunity. If you design your floater well, you could install or assemble your turbine already at the yard, onshore, as we call it, and install the whole thing at one go. And as you probably can imagine, onshore hours are cheaper than offshore hours. A very quick look at financing structure. There are two distinctions to be made. On the one hand, corporate finance versus project finance. Project finance typically where you have a special project vehicle that pays back the loans from its own cash flow. On the left, we see a graph depicting the difference, the ratio between corporate finance. You see that project finance typically dominates that. The other distinction that we can make is debt, non-recourse debt, especially in case of an SPV, versus equity. The various sources are listed there. We're not going to touch upon that in this course, but what we can say is that typically we see the offshore wind trending towards 80% debt, 20% equity. Building blocks of project finance. Well, of course, having a good eye for your costs and your risks is important. There are more topics that are important for a robust project finance strategy. And they all help with getting a higher bankability. I'm not going to go through them all. Maybe one interesting item to take out of this is your debt capacity, your repayment profile, also your resilience. If you have a couple of months where the wind doesn't blow as hard as you thought, or maybe even in a year, and we cannot control nature, that will have less revenues, but you still need to maintain your asset organization and you have your repayments. So especially under stress, how resilient is the SPV for obligating its duties? Revenue mechanisms are very important. We already talked a bit about the CFDs that help there, and the power purchase agreements that give you certainty over a certain duration. But also you could have an additional revenue stream with renewable energy certificates. There again, we have the two-sided CFD that is now proposed for Italy. And we should mention that there are ongoing dialogues with the developers on whether those initial conditions are the correct ones and maybe whether it should be split between fixed and bottom, because they are really different projects in nature. Quick overview of the SPV in relation to its other stakeholders. On the left-hand side, we have the parties that give the money, whether that's equity or debt, and they get repaid in respectively dividends or repayments. And on the right-hand side, we have the stakeholders that make the project happen, the contractors, whether the EPCI or the operations and maintenance contractors, the CAPEX and the OPEX flows to them. In return, they will manage the construction and operational risks. Of course, there's a balance there to not increase the CAPEX and OPEX too much. I hope this one speaks for itself, so I will continue with the project development strategy. Hendrik already showed this picture, and what we see here is a typical stage gate model. We define the project in clear stages, and between that we have decision gates. And with every gate we have de-risked the project a little bit further, and we add further value to the process. And it's important that we define those gates and stages. These are the 5 typical stages and sub-steps that we have in between, from the strategic planning all the way up to the operations and maintenance phase. It doesn't stop there. The decommissioning is not shown here, but that's really a different kind of animal. Then a closer look at those decision gates. Again, it's very important that they are defined in a quantifiable and objective way. So at every stage gate, you look at your objectives. Did we meet them? If not, we give ourselves homework. If we met them, we continue investing in the project until hopefully at one day we reach the financial close. All is done. We have the design frozen. We have the contracts in place with the contractors, and we start building. This process is largely uniform over the world, and for large infrastructural projects, what is typical per country is usually permitting process, which Imke already explained a bit for Italy. The 4 important permits that you have for Italy are listed there. You have your grid connection, which can take quite long. You have to show that you are in compliance with Terna's grid connection requirements. You've done your necessary engineering and you show that you can connect. The environmental permit, very important as a result of a successful environmental impact assessment. Now the conditions and the limitations that you have to show how you deal with that. You apply for a maritime concession, which in turn gives you right for the building permit. And typical for Italy, you can be helped by applying for a shorter term permit that allows you to do surveys at the site, which gives you then information that help you with the environmental impact assessment. I'll come to my last slide. We've said that a lot already. Risks, it's our favorite word for project development. They apply to all stages of the project and for all the parties. Here are the 5 main categories that we think are important. Technical risks associated with the site conditions and the uncertainty related to those. But also costs related to the supply chain. Supply chain is very important, especially in emerging markets. Are the contractors available? Are there assets available for when you want them? And very important also for Italy, are the ports ready? The marshalling harbors, and does the government help the ports to invest in the necessary hardware to make offshore wind happening? I think the other risks all speak for themselves. And of course, more in our course where we go deeper into what those risks are and how you can manage them properly. So then I'd like to give the word and the mouse back to Hendrik, who will go in a little more detail on the development phases.
Yes, thank you very much, Leon. That's very much dependent on the policy, also your marine spatial planning that you have. Not every site that you think can be used for offshore wind can actually be used for offshore wind. Then of course there is site identification and leasing. So okay, what are the specific sites that you can actually do? Are they screened? Are they accessible? Can they be used for offshore wind? And early site assessment. So what's the suitability for these sites? Like Leon was saying, permits, you see that to your right. So basically, I like to keep that short. There's a few permits that you have to get. So there's the spatial site-related permit, technical infrastructure permit, environmental permit, structure and operation permits. They all come together into one point, which is, of course, where your site will be. Yeah. So then its next phase is the design and engineering phase. Well, design is a very iterative process and continuous, keeps on changing all the time. Put them into a funnel, as you can see to the left. In the full course, we will spend like 45 minutes, like a total presentation about this. So this is just one overview of this. So it will be conceptual start. So what could work? What will happen? What are you thinking about? And look about the permitting and consenting. That's usually envelope based. So think about this as literally as an envelope that you hand in to get your permit and say, hey, I'm going to build more or less so many turbines. These are the foundations that we're going to use. So you won't be actually put to exactly what you're saying there, but basically give it like an overview. Then comes your feed, so your front-end engineering design, thinking about the first things, what can we do, what is it that investors are willing to fund. You give off like 10, maybe 20% margin of costs. After that, you have your financial final decision. So you go into detail engineering. So what will we be actually building? What are actually the costs to do that? And that's all beyond the FID, final investment decision that you have to take. Then to see the picture on the right, actually, I took that picture not so long ago, I think last month, when it was very cold in the North Sea. And you see all these guys looking at part of the design, and there will be some changes around that. So yeah, the engineering, as I said, is the proof layer of the design. Will it work, and make sure that it works. So some innovations as well to be used. So when you have your design, everybody's happy, we go to fabrication. So I'll just show you an overview of that. Again, this will be a 45-minute lecture, so just trying to break this down into one slide. I'm trying to do my best here. So on the top left, you see Esbjerg in Denmark. It's a really nice overview of a fabrication yard. You see the blades, you see the tower, you see the nacelles as well. So you have an overview of all things that come together. That's really important because you know, your turbine blades, tower could come from one OEM, as we call them. But also you have cables, substations maybe coming from a different country. And to your left, bottom left, you see a floater from France has been used. And you can also see a little bit of the size because you see the tugboat to your left. Again, I took this right picture about transport and installation myself last year. And what you see here is a jackup in green, and looking for the installation of one of the wind turbines in the Dutch sector. Now, when you look at Italy, interesting to note, there's already a few offshore wind ports that are designated for Italy. Augusta is one, which mainly will be focusing on storage, but also looking for floating device. I've actually visited Augusta in my Navy days, which was like 25 years ago, I think. But also I visited Toronto and Brindisi, and Toronto, I'll show you a little bit about that more. There's also a designated port, as is Brindisi as well. Ports are very important, usually very underrated, and that's something to really think about. Your first wind farm in the Mediterranean is actually from Italy, from Toronto. As you can see, it is a monopile construction. You know, the water depth is anywhere between 8 and 30 meters, and your wind is, and you can see that by the blade selection, and also by the selection of your turbines. The wind conditions are around about 4 Beaufort, so say 6 to 7.7 meters of wind speed. Nice pictures. Again, we look at this and we will use this for our kits. Now, everything is running. Yeah. And but then there's one thing that you also have to do is maintain it. So I showed you a few types of maintenance. So basically it's preventive maintenance and corrective maintenance. Corrective maintenance is easiest. You just let it break down and then you go repair it. But of course, that might not be the most optimum solution. So you also think about preventive maintenance. And when you go back to my picture with the turbines, you know, preventive maintenance for gearbox-driven turbines is much higher. You have to go out at least once a year, some oiling and greasing up. Corrective maintenance, you know, some could be a thing for that as well. So strategy, you have to find out, how do I go there? Do I go there by crew transfer vessel? It's very small, do quick work, or an SOV, which is a vessel with a waterworks system, and you can do more and more maintenance. In any case, what you have to do when you have to replace your gearbox, it will be jack-up based. So all these costs you have to come into account and go for the optimal maintenance strategy. Again, maintenance will be, I think, an hour in our course, so I will be talking to you in great depth about that. But I like to hand over final word, I think, to Imke.
Yes, thank you, Hendrik. So just 2 more minutes for me to tell you a bit more about our full course, the Offshore Wind Development course. We've been given this course now for about a decade globally. So what is it about? It's a 2-day in-person interactive course, which can be customized also to the specific country where we give this course. So in this case, of course, for Italy. So it contains about 10 lectures given by experienced senior specialists with over 20 years of experience in offshore wind, but then also accompanied with 5 practical cases during which you will develop your own offshore wind farm. Then the final step is that we look at the design choices that you have made and also assess those with an LCoE model, just to check the project viability of your offshore wind farm, but also to determine what you could have done differently or better. So on the left, you see all aspects that are discussed during this course. And I hope we also gave you with this webinar an overview of what you can expect. Then about the practicalities, what you'll find here is the website where you can register for this full course. We have already selected a few dates. So we plan to give 2 courses in June this year, June 1st and 2nd, and then another edition on June 4th and 5th. The locations are not decided yet, and it will be decided upon the preferences of the participants. So when you register, also please let us know what is your preference for the location, and then we'll pick the location that fits best with these preferences. Also, if you have any additional questions about this course, please feel free to reach out via our course coordinator, which is Celine Ummels. You can find her details here at the top. And if you have any other questions about this webinar, the services that both AFRY and Green Goose Solutions can offer in offshore wind, please feel free to reach out to us. And then, yeah, I'd like to say thank you very much. And I'm going to say ciao for all of you.
Grazie.
Grazie and ciao.
Thank you and bye.